Hello guys, this is Abhishek and Ajay. We are here to present a topic which is on missionaries and cannibals. Problem statement. The missionaries and cannibals problem is a classic puzzle in artificial intelligence and computer science. It involves three missionaries and three cannibals who want to cross a river using a boat that can carry at most two people. The catch is that if any point the number of cannibals on either side of the river exceeds the number of missionaries, the cannibals will eat the missionaries. The goal is to find a sequence of boat trips that will successfully transport all missionaries and cannibals from one side of the river to another side without violating this rule.
And now the states and constraints. There are two types of states, initial state and the goal state. Initial state. At the start, all three missionaries and all three cannibals are on one side of the river along with the boat. Goal state. The goal is to get all three missionaries and all three cannibals safely to the other side of the river. And coming to the constraints, there are three types: the boat capacity, cannibal rule, and the safety. Boat capacity. The boat can carry at most two people, either two missionary, two cannibal, or one of each. Cannibal rule. At no point can the number of cannibals on the other side of the river exit the number of missionaries, or else the cannibals will eat the missionaries. Safety. All individual, that is the missionaries and the cannibal, must be safely throughout the entire journey. And coming to the production rules, there are five types. Rule number one: cross with one missionary. If there is at least one missionary on the initial side of the river, move one missionary to the opposite side. Rule number two: cross with two missionary. If there are at least two missionary on the initial side of the river, move two missionaries to the opposite side. Rule number three: cross with one cannibal. If there is at least one cannibal on the initial side of the river, move one cannibal to the opposite side. Rule number four: cross with two cannibal. If there are at least two cannibal on the initial side of the river, move two cannibals to the opposite side. Rule number five: cross with one missionary and one cannibal. If there is at least one missionary and one cannibal on the initial side of the river, move the one missionary and the one cannibal to the opposite side. Finally, these rules represent the possible actions that can be taken at each step of the problem solving process. They can be applied iteratively to reach the goal state where all individuals are safely transported to the opposite side of the river. Now, let's take a glimpse of this game.
Here we have three missionaries and three cannibals. So firstly, we'll take one missionary and one cannibal each into the boat and make them move towards the opposite side, dropping one cannibal on the opposite side and bring the boat backwards. And then now, let's take both the cannibals into the boat and drop one cannibal and bring the boat backward. Here, now we take two missionaries into the boat and make them move towards the opposite side, dropping one missionary and taking one cannibal into the boat and moving backwards towards the initial place. Now we'll board another missionary into the boat. Now all the three missionaries have reached the opposite shore and one cannibal is supposed to bring the remaining two cannibals from the opposite shore. Yeah, on picking the final cannibal from the opposite shore, the problem is completed. Now all the three missionaries and cannibals have reached the opposite side. Thank you.